Welcome to our weekend call, our weekend Bucky call for July 4th and 5th. Um, and of course, it's Independence Day here in the US, but we didn't make a big deal out of Canada's Independence Day on July 1st either, did we? We kind of ignored it and let Richard suffer on his own. So we'll just leave it at that. And Richard's not even here to enjoy the joke. Joe said he would be able to show up. I don't know where Richard is, and I'm sure Manu will join us in a few minutes. And Fred, I'm counting on you to conduct our book, right? You're the one who's in charge of our reading. We're doing Programming the Universe, which is very exciting. Very exciting stuff. Anyway, Lee, how are you feeling tonight? Uh, and what do you expect to get from our call? It's your turn.
I had an experience that happened to me that kind of devastated me and those that I was with. My blood sugar refused to come down. I had run out of insulin, and that did me in pretty badly. And so I had to sleep it off last night from a 500 blood sugar down to, you can't believe, 29. I woke up with a 29 blood sugar from 500 straight down, straight down. It took me all night, but I feel great today, no matter. And I'm excited to learn more about this great book. Fred, how are you doing?
Feeling. Go
Thank you,
ahead.
Lee. Today is a good day. Every day that England gets beaten by 50 points by any rugby team is a good day. So Britain got whacked by South Africa, and yes,
Maybe that's maybe that's
uh,
why
uh,
Joe. That's why Manu isn't joined us. He's probably celebrating, and maybe he can't give up the
Manu
point.
is Manu is still passed out under the rafters.
There's
All
Joe.
right, and let's learn a little bit something today. That's my expected
Oh,
takeaway.
here comes Joe.
Hey,
And
Hi,
how are
Joe.
you feeling today, and what is your expected takeaway?
Oh, thank you. A couple of things. First and foremost, Steve, thank you so much for now having our meetings in transcribed, yeah, because I went in and I could follow the meeting in like less than half an hour, which makes a huge difference. It was also partly because I read the book from the last meeting. Yeah, I knew which page we stopped at, so I read, and then I went down the path of looking at what was written, and so that was powerful. And so maybe before we begin the reading, I have a couple of either comments or questions, yeah, regarding the discussions that went around the reading last week. It was really powerful for me, so I would love to um, you know, uh, put my 2 cents worth as in the question part and also the realization part. Yeah. And the other thing was I will take this up further on Wednesday because it has to do with the Bucky Dome. But I need to share it today because yesterday we had our Biosphere Appreciation Day for our students. And it was in a dome. That dome, similar to what I visited in this Eden project in the UK. But of course it was a smaller one, enough to put in I think about 200 people for a dinner. So all the lights and I'll send the photos. It was beautiful. So we had it was very time. It was fitting that we did our Biosphere App Day, because that lot of parents and students are the most aware of issues and the larger scheme of things around the world. So and then the other thing was the developer was talking about they wanted to do a biosphere school. Oh, maybe that one I'll do it on Wednesday. I'll update this what's that Wayne at the same time. However, so yeah, it happened. Okay, yeah, I'll leave it for that. Yeah. So but it was beautiful. Thank you. And okay, so Joe, how do you feel and what would you like to take away today?
I'm feeling good. It is, the fourth year in the States, and that's our Independence Day. And got to see some fireworks, so that was really nice. Yeah, as far as my, expected takeaway is concerned, and actually, I really appreciate what you just shared there, Anne. Regarding your Biodome Day. But it's actually just to have that deeper exploration as to what information is and what does it really mean to be precise with information. And so I think that that's really the more precise that we can be, whether it be with our words or numbers or whatever it may be, the more capable we are of shaping the world and ourselves. And I was just having a conversation about cause and effect, and even this idea with the ability to determine cause. And what it really takes to be able to it. And part of it is the ability to explain it. So this idea of precision, the way it's being covered, is actually going to be interesting to explore with the group. Now, that doesn't mean that words and logical systems capture everything, but at the same time, it does mean that it makes us more aware. So anyway, Richard, you just come in. So how are you feeling, and what would you like to take away from today?
Hi, everybody. I appreciate the recognition that I was going to be a little bit late. Just had a wonderful on the road A&W hamburger and chips. So how's that for a nutritious evening meal? I'm feeling good. We just spent the week with our daughter in her new home and celebration of life of her husband, who unfortunately died back in January, which I've shared. But it was a good time together, a good experience of seeing the support that she has with her friends and other colleagues, and to spend that time in her new home. What am I looking forward to? I guess in terms of program in the universe, I'm interested in how the sensitive dependence on initial conditions vis-a nonlinearity cause and effect will play out in our readings, and how we can dialogue about, if you want, linear proportional cause and effect and nonlinear disproportional cause and effect, and the sensitivity that is grounded on that in terms of the initial conditions. So am I the last one to go? And
Manu still has to go.
oh, where's Manu? Manu, how are you feeling? What's your expectations for today?
Good morning, the best to our American friends celebrating the Independence Day, the Revolutionary Day. I'm happy to be here and just get on board the train and grow from this experience. It's one more experience of life. Hope I go full circle and then put one more layer on my symbols and grow. That's where I am. Who's next? Is Steve? Yes, Steve. How do you feel? What shape are you?
I actually
And
already
what do you
went.
think?
I think I already went. Maybe I didn't. And
No.
I didn't go. So Manu, you picked the perfect guy. Hey, I'm feeling pretty good. Yeah, we had a 4th of July weekend. I mentioned earlier the jets flew over the place at 8 o'clock and it scared us. It's too, it's America's big on military. We could be big on other things, and maybe we're going to get there one day. So, but our national anthem bothers me too because it's all about bombs and our flag was still there, but we could do better than dropping bombs. All right. So other than that, I'm excited to begin our chapter 2 on computation. Looking forward to our conversation. I really liked Anne's suggestion about talking about whatever her review and whatever topics come up. Good. And Fred, I'm turning it over to you, dude. You are in charge of this deal.
Thank you.
You're the conductor, and so please tell us how you're feeling and go from there.
Okay, I've said that. I wanted to react to your America is big on bombs and all that. I think America should stick to what it does best, which is not bombs, which is music. And if America would stick to music, the whole world would be such a better place. That's
Yeah, it's funny you're saying.
so
It,
that's it. And then Manu, you look like you're about to die. You just beat England by 50 points. You should be happy.
We are world champion. So
Yeah, well, you don't look like a world champion. You look like you should be in hospital.
now I'm just waking up. Really.
Yeah,
Literally.
well,
I just
if
put
I was
water on my
if I
water on my face, put on this stuff, and I was here. That's
when
what
I
I
look
did.
at you, I think you should avoid going to bed. It doesn't do you any good.
Do not tell us you're not wearing pants, okay? Just
Hmm.
we like the scarf. We
No,
like
no, 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 no,
no,
no.
no, it's okay. No, don't do it.
I'm okay.
Too much information.
No, no, no. I'm okay from that point of view.
Okay, okay then.
Okay.
Okay. Did I interrupt you, Fred? Go ahead,
Can we-
Fred.
Okay, let's go.
I'll just
Steve,
say,
will you
Fred,
share-
really quickly, is that when I was at the World Cup game, everybody was singing American songs with their own lyrics. So yeah, maybe yeah. So that was actually it was an interesting experience that so they took the tunes and they actually just put their own words to them. So I think you're onto something there.
Yeah, well,
It was the spread of MTV that you could see. It was definitely a lot of 80s tunes.
yes. Well, I've been saying that for many years. Maybe one day we'll get there. Anyway, Steve, are you going to share the book or should I share mine?
Yeah, do we want to have a discussion of Anne's points? And maybe have some specific points you wanted to bring up.
Okay, maybe I want to ask again your question then, because I didn't make a note of it. You muted it.
Yeah, I forgot. I wanted to say this about the domes, because I had 5 minutes to speak to the parents, right? Because, and I talked about AI proofing, right? The kids, and I think my biosphere students are the most AI proofed. And I managed to end it, and I told them, I said, at the end of the day, the dome, and I talked about the dome and food Baki, and I talked to them about cosmic integrity, world being eternally regenerative, and nature has no pollution. And the cosmic accounting, I managed to put that out there, and I said, "This is what we are leading. What we are leading the biosphere program with." So I thought you'd be very happy. Now I have 100 over parents, sets of parents. That means families, hearing that, and they brought friends and even relatives along. So yeah, I'm really thrilled with that one. Yeah. So coming back to the reading last week, there are two things that came up. One is the one on the human experiment on human intelligence. Yeah, I really like that one because you know, the outcomes of it. And when Fred shared about eugenism, they actually did an experiment on the Nobel using the genes from the Nobel Prize winners to try to create in vitro the smarter children, right? So thank you for that one. Yeah. And because so that's the one. And the other is, Fred, you said something about the results. It should be the same whether it's Tuesday, Wednesday, or that it and wherever in whichever country, right? So I just want to
Yes.
check in on this one because this quantum physics, and it started when I read this book, James Rollins. The storybook is called, it's a storybook, James Rollins, and he wrote a book called The Black Order. So in that story, the premise of it, in that book that came out, the way the quantum world behaves is so different from what the laws of science have been, right? And there is this, and so I went to check in on the definition of physics, of quantum physics, right? And that exactly is the one where maybe I can read it to you, The fundamental branch of science that studies the behavior of matter and energy at the most microscopic scales, right? And there's one part that it says the uncertainty principle, because in the book, it's like the atoms can be in one place and more than one place at the same time. And then it moves in a manner that we cannot predict. So then what happens? How does that? I'm just putting it out there. We don't need an answer. And then at the same time, the unpredictability of the way these particles move. So it was when I read it, I was like, wow, that really should explain a lot of the world, because many things didn't quite fit into the laws of physics as we knew it at that time, right? And I haven't even done much science, in terms, but when I read the book, because it's in a story, it makes it so much easier to understand. Yeah. So anyway, that's where I'm coming from. I've got the, it says the key concepts of the quantum world. So the wave-particle duality, the superposition, quantum entanglement, and the uncertainty principle. If you all would like, I would love to. I kind of took it out. Maybe if you want, I can send it to you. All right. And the other thing is this. In the book, right? Oh no, it's not in here. It's in here. Sorry. Yeah, they kind of wrote about the nature of the book, right? And this James Rollins was exploring the nature of reality and human consciousness, the concept of quantum evolution, to explore how human consciousness and focused intent on influence reality at the subatomic level, bridging the gap between faith and quantum science. That was what his book was about. Yeah. Okay. So I just want to put out there because I would love to hear, if you have anything to say to add to that, or we can go on and find out more about it in the book. Yeah. Thank you. I hope that
Thanks, Anne.
interest.
Thanks, Anne. That's a lot of questions, but I think Manu has something to say first. So Manu speaks, and then I will answer your question.
Okay, Anne, I want you to listen to me clearly, but I think that I might be wrong, but just listen. We have been studying whole things. We have been saying everything can collapse into a tetrahedron and expand to the cube octahedron. That's one thing. Secondly, we are saying we are inside. So we are in between two things. Because if we are inside, there is a micro and a macro. And if you take the spheres of relevancy that Steve usually exhibit, you see that there is a micro. My definition of quantum mechanics is the study of a micro, the analytical study of a macro. Because there are no laws there that we know. We can only have laws between whole things.
Okay.
So when we study, we try to see what is going on at the micro level, that is at the local level, at the reality level. We have to go to things that are bizarre. Remember, we try to divide the tetrahedron, and we quickly arrive at things that we cannot account for after a certain number of divisions. So the laws between those things are probabilistic laws. It's the law of numbers. And the things that we see, which I come back to somebody, I think it was Steve or Joe, that was talking about cause. And we discussed this cause last week, that what we see, the cause is not the immediate thing that we saw before or that we felt before. The cause is many other, smaller, that is far away from us, seen from us. Think of the way you develop flu. Is it the handshake that you had a week ago with somebody who had flu? Is it the kind of rubbing of your nose after that? Is it something else? You don't know. You can only define probabilities for that. And those principles of uncertainty, for example, is derived from the fact that we are double, we are inside. And secondly, with our mind, we can still, even when we divide that stuff, we can only still see half of it. That is an effect of something. We cannot see the cause and the effect. Therefore, Heisenberg defined a practical principle to allow people to do calculations. That is probability is finer and finer. That is one. The second thing is things can be at many places at the same time. Because remember, even the time that we define was at the level, the finest is our micro. So it is same time. Time can be abstracted inside that thing. So many things can be the same thing or the same perception of it can be at many places at many times. Many places at many times is a possibility. So that is my understanding, and that's what makes me, separating that, again, the theorem of residues, I separate that and allow me to be sane. Otherwise, I go insane. Thank you.
Go
Thank you
ahead.
very much. Yes, thank you. That helps.
Yeah, I'm just going to make a quick comment here is that, the conversation that I was having about cause earlier was the idea that, one of the things that we can say that is intuition is sometimes when we're unable to explain as to how we come to know something. That there is this unseen, as Manu was just talking about a moment ago, that there is this thing that we tend to follow. You can call it, intuition. As we're following it, as it's um, a gut reaction to something, if you will. And there's one reason is that we're trying to understand something. So this means is that we're not just thinking in terms of a set of rules, that we're actually seeking to understand something, and there's something in that there's an intuition that we just don't understand how to explain yet. So when something happens is that we're not able to even necessarily explain the cause. All that goes to the idea of the, kind of this quantum level where we're not seeing things. And so this is related to how we behave and how we actually start to begin to understand the world. So anyway, that's just some thoughts really quickly as to how when we're thinking about this in terms of quantum levels, how it relates to our conscious experience. So from that perspective, even information that fed that we're just not necessarily aware of how it's impacting us and how that relates to intuition is also, I think, an interesting thing to think about a little bit more deeply. Anyway, that's just some thoughts as far as I liked the idea when you were talking about domes and cosmic accounting and things along those lines, just thinking in those terms. And when you're talking to parents about that, I think that that's the most powerful thing that any teacher can do, in the sense that you're getting them to think about not just the grades that their kids are getting or things along those lines, that you're actually getting them to think about what does it really mean to live? And that also is looking beyond just the numbers. So anyway.
Thank you, Joe. Anybody else before I try to address Anne's questions? Okay, so let's go. Quantum mechanics is about the study of description of atoms, electrons, photons, and the smaller scales of reality. Basically, at our scale or larger scale, there's no quantum effects. Quantum effects happen at the micro level. So it's a study of the micro. Basically, if we want to describe the macro, it's general relativity that we use. The problem physics has is that these two are not compatible yet. They're not reconciled. There's something missing in between, and notably missing is there's no quantum theory of gravity that works. There's plenty of theories, there's plenty of hypotheses, but they don't work. So we don't know how to make it work. You talked about what happens on Tuesday and what happens on Wednesday, or what happens here or what happens over there. It's the expression of conservation laws. Quantum physics doesn't negate the laws of conservation of energy, conservation of momentum, all the conservation laws that are described in general physics, in classical physics, in classical mechanics, are the same. There is a conservation of momentum and conservation of energy, and all those conservation laws apply in quantum mechanics. That means if you have a universe where today some physical law behaves one way and tomorrow it behaves another way, that's a violation of conservation laws, which does not apply in a theory of quantum mechanics, which means that your observation is inexact. You have to review your observation. It's not possible. The same happens if you observe something here and the same thing that you observe elsewhere doesn't behave the same way. It's a violation of conservation laws. This cannot happen under quantum under quantum mechanics or under classical mechanics. The same thing happens. Same thing is there. Now you mentioned superposition. You mentioned particles can be at the same place at the same time. That's how superposition is presented. It's presented as particles being at multiple places at once, having multiple properties simultaneously. This is magical thinking. This doesn't exist. What happens is that superposition is vector addition. That is, a quantum state is a vector in a Hilbert space, without going into detail about that is, but that's vector addition. And any vector can be written as a sum of other vectors. So superposition is a sum of several vectors, if a sum of several quantum spaces which are vectors. That is, if a quantum space is defined as a vector in a Hilbert space, two quantum spaces can be added together and they produce a vector, which is the description of the particle at that moment. And the way it's popularized is that it's one particle can be at two places at the same time. No, it's not. It's the same particle have a probability of being there and there or there at the same time. But it's a probability. It doesn't say the particle is there and there. It says the particle has so many chances of being found there or so many chances of being found there. So superposition is a linear algebra, it's a vector addition. Then you say consciousness and evolution. I think these are two different concepts. Let's first talk about evolution. Evolution in quantum mechanics is most of the times used to describe the evolution of the wave function described by Schrödinger. The evolution of the wave function is deterministic. That is, if we know the value of the wave function now, we know the value of the wave function at any other time prior to that and any other time in the future. This is entirely deterministic. If you remember our small models of physics that we used with several states and transition from one state to the other that I did with my camera setup, this was also deterministic. With one, if you knew the state at one moment, you could go back in time and knew what the state was at any time in the past, and go in the future, you could know what the state would be at any time in the future. The states in quantum mechanics are described by the Schrödinger equation, by the wave function. And if you know the wave function at any time, at one time, you know it at any time. It's deterministic. What is not deterministic is measurement. The moment you want to measure, then the superposition becomes determined, takes a value based on the probabilities defined in the wave function. Consciousness. Any questions so far? Let me keep going. Okay. Consciousness. This is going to be a shocker because most of popular renditions of quantum mechanics talk about the influence of human consciousness on reality. Well, the fact is that the observer does not matter. Usually we are told that observations affect reality, that the observer collapses the wave function, at least in some interpretations, and that consciousness plays a role. It doesn't. It's measurement that does, and measurement is not a human process. Measurement is a physical process. That is, measurement involves the interaction between the quantum system and the measuring equipment. And the equipment, the apparatus used to measure, is a physical system, not a conscious observer. The measurement happens when the quantum systems become entangled with the macroscopic apparatus that records the result. Consciousness is not relevant in this situation. The detector measures an electron, whether a human looks at the detector or not. And a photographic plate records an interference pattern, whether anyone develops a film or not. So consciousness does not require an observer. It requires a physical interaction that usually is through a measurement. And it's said that the confusion arises from the word observation. In physics, an observation means a measurement, a physical interaction. It doesn't mean conscious observation by a human. It's an unfortunate terminology. That's what I wanted to say about your questions. Did I answer? Did I answer a little bit your questions?
Yes, thank you very much. Thank you so much for taking the time to do this. Yeah.
Yeah,
And thank
well,
you, Joyce.
I've worked this week. It's not fully ready yet, but I've worked this week on the main differences between what quantum mechanics, the theory of quantum mechanics says, and what we are told, what popular renditions of it, the popularizers, the people that tell us about it, so for the general public say, and there's quite a bit of discrepancies. I've got 10 discrepancies points, and I've just mentioned 3 of them. So maybe maybe next week or maybe the week after, I'll do a distraction from our book and tell you about distinctions between popular quantum mechanics as it is presented to the public and what the theory really says about quantum mechanics, in order to fix our ideas, because we all get carried away by it's portrayed as mysterious and magical, but it's not so mysterious and so magical as it's presented to us.
Thank you. Thank you very much. And thank you, Joe, as well.
Thank
For the earlier, yep.
Richard, please go ahead.
Yeah, I just tried something. I guess it's an AI comment, but manager. I was trying something that might speak to what Anne is, presenting to her students and her parent and the parents. But I typed in where to go here. Quantum physics is about relationships. Material physics is about physical entities. So this is the answer I got. It said, your statement beautifully captures the core insight of relational quantum mechanics, popularized by the theoretical physicist Carlo Rovelli. It suggests that the fundamental constituents of reality are not isolated physical objects, but rather the webs of relationships that connect them. Then it goes on and says, quantum physics about relationships at the subatomic level, particles do not possess intrinsic independent properties like a definite position or speed until they interact with another system or observer. In this view, reality is an immense network of encounters, and entities' existence is entirely defined by how it influences and interacts with its surroundings. Material physics, about physical entities, traditional materialist and classic physics approaches tend to view the universe as a collection of solitary substances. It operates on the common sense assumption that objects inherently exist as things in themselves, possessing fixed physical properties regardless of whether they are interacting with anything else. So that was just a very quick sort of AI response to my assumption that quantum physics is about relationships and material physics is about physical entities.
Okay, thanks, Richard. We need to keep in mind the scale. Quantum deals with very small, whereas classical mechanics deals with human scale, and general relativity, which is part of classical mechanics, deals with a huge scale, with larger scale, macro scale. But thank you for your AI exploration.
Well, I think the other thing is there's been the assumption that what we know in the physical material world is going to be found in the quantum world. And that's why the search has always been for the basic building block, the basic solidarity. And when I was reading and connected with Margaret Wheatley and chaos theory and that sort of thing, it always said that as the physical scientists got closer and closer to trying to find the ultimate building block, they kept running into a problem because all they could find was relationships, the connections in between. That was another kind of description between quantum and physical, or micro and macro. Yeah.
And the limit to that is the book we're studying. It's information.
Okay. Thank you.
Thanks, Richard. Joe, please go ahead.
Yeah, I mean, actually, I was kind of got a little bit distracted there for a minute because I was just off of the comments. But I mean, in a way, that thinking about things in terms of a network, it's how things. It's a constructivist's approach. The way I look at it is that that they are a set of relationships between entities, and even as this is kind of like how even our minds work, in the sense that because I bring this up because we talk about this in terms of quantum evolution and the idea of how the mind works, and there is the Roger Penrose idea that we're not necessarily thinking in terms of algorithms, that we're actually thinking that the consciousness is found at the quantum level. And so and Stuart Hameroff focuses on the biological aspects of this, and there are questions about their theories. So it's not to say that we have an absolute rule here, or there's an absolute one way of looking at this. But one of the important points is this. In reading actually essays, and I was mentioning this to someone earlier about Montaigne, and how we're basically how the personalities, or even who we are, changes based off our interactions and basically our ability to regulate our emotions, but that they're situationally dependent. So the reason I bring that up is it's about maybe the interactions that we have that has an impact on behavior. And so that those interactions are actually those continuous interactions over periods of time are really what matters. And the reason I say that is this whole idea of a self, or whether you want to call it a self, is just a series of interactions. It's not necessarily something that is fixed. So when you think about things from that perspective, it gets into this to even what does it really mean to be an observer, and then how that relates into interactions and uncertainty. Yeah, I'm done. Sorry.
Well, there's no hands up. Yes. Are you done, Joe?
Yeah, I'm done.
Yeah, thank you. You mentioned two things of interest. One is you mentioned continuous interactions. If it's quantum, it cannot be continuous. It has to be quantized. That is, there has to be some quantities identified. The big difficulty of quantum mechanics is the quantum part, is that energy and everything else comes in packets that you cannot divide anymore.
Right.
So it's a series of, you say continuous and then you say the series of interactions. I think it's better to say series of interactions. A continuous series of interaction maybe, but continuous interaction is a little bit misleading in the quantum sense. And the second thing is you say what the observer means. The observer is a measure, is a measurement. It's a physical,
Right.
it's a physical interaction that the measuring instrument does with the quantum system you observe. That's what the observer is. As I mentioned a bit earlier, is that whether you develop the film that takes a picture, and then, or whether you have a human that observes the equipment, doesn't change the fact that the equipment has an interaction, has an influence on your system.
No, and that makes, yeah. I mean, and I think that this is essentially, is this also speaks to the, how does somebody's measurements, how do they come to determine if their measurements are correct, is really the important question with that, because then you're getting into their judgment, and how judgments are then made, and they're made based off of our interactions, because that's what your measurements are shaped by the environment that you're in, even the tools that you use. So I mean, that's also important to kind of consider, is that when we're talking about everything is about measurement, that's judgment. That's, basically in the sense
I don't
that
know.
there
What
is,
you do with your what you do with your measurement is probably judgment and consciousness involved, but the measurement itself, whether you look at it or not, happens.
correct.
So there's no judgment there. There's no judgment there. It's just measurement.
Well, that's an important distinction, because then it becomes between the impression and then the assent to the impression. So our minds have an impression, and then whether we act on it or not, right? So that's something that's really important, actually, and even just in Stoic philosophy, is that when we look at it, is that we have feelings or impressions about the world. However, whether or not we give assent to it is another question. So that's you're right. That distinguishing characteristic is judgment within that frame. And then that's where we get into the importance of what does it mean, and something I've been looking into deeply lately is attention. But I won't go into that right now. But I appreciate that explanation to that.
Yeah. Just one further point before we go to Anne is that the human mind and the human brain are not, I mean, the human sensory system is not calibrated to measure quantum effects. It's too small. We cannot see it, we cannot feel it, we cannot observe it. We need to go through a measuring instrument, an apparatus, a physical system that does a measurement for us.
Right. And so yeah,
it's not like we observe what's happening next door with a neighbor. It's this you can observe directly, but in terms of observation measurements of quantum systems, you have to have very sensitive equipment that can see,
absolutely,
that can detect minute interactions.
Absolutely. No, and that's really important as into how that actually would impact even behaviors as well.
Yeah.
So because we're not aware of that. So then that gets this
Yes.
idea of to what degree are we even conscious of those things? Like, so that's where, and that's what, starts to, we're also starting to distinguish a very important characteristic of algorithmic thinking versus, kind of thinking in terms of quantum, if you will, where we're kind of trying to reach a level of understanding and even what it means to understand within that frame. Anyway, I'll leave it at that.
Thank you, Joe. And
Yeah, at first I want to say thank you so much because, two things. One is that it makes it so much clearer for us, for me in particular, moving forward with this book, because the book has no time to go into what quantum physics is or quantum mechanics really is, right? But I mean, we will learn more, but the whole thing at the big level of and the fundamental um, understanding of it was just set up here, right? By all of you who just spoke about it. So it is such a perfect like a grounding before we move on with the book. That's how I feel. Yeah, thank you very, very much for that. The other one is, I think right there itself, you see the missing link, not between material science and the quantum physics, but between with education, right? Education and the world, because there's no teacher who can do this kind of links in the classroom for the kids. None in general, because they're trained to teach physics, they're trained to teach, but you don't really get engineers to come into classes to do this. And even in my school, my engineers are still very young people who have never. Yes, they came in. Some of them worked in the engineering field, but they've not done big, massive, scale of construction or businesses or in the industry, right? And so that there is still that bit of a, but they're able to at least link better than most. But that's exactly what is missing, the link between that and the teachers cannot. So it leaves you from school with so many things that you have no idea. And the worst part of it all is when you don't get it, you feel stupid, and you're made to feel stupid. Unfortunately, not that there's a piece of information, many pieces of missing information. So thank you. And the last thing to add is that this book now has got. Last week I mentioned nature, right? Nature linking to bits and programming, and this past chapter was about language. Wow, never thought they could meet in the middle. So thank you very much. Yeah, I'm very, very good here. Okay, right.
thank you, Anne. Manu.
I think it can be made a little bit even easier. Imagine a fish, imagine a pond. You know this artificial pond that you have in the house. You have an electric pump, you have a tube, get in, and then there is a cage with water. And the pump is just running at a certain frequency. It's playing its music now. And then you have bubbles going around in the thing. For as long as there is electrical power to run the pump, it's playing the universal music.
Mm-hmm.
Now take a fish and put in that pond. The fish is just going to do what it was made to do.
Mm-hmm.
That is going to swim.
Mm-hmm.
By swimming, the fish is created and is anti-entropically, not conscious. Consciousness has nothing to do with that. It just want to survive for what it was doing. It is creating waves. just by being in water. It's creating, so if you had waves that were going this way, the action of a fish to survive is going to go that way.
Mhm.
That's why I call it anti-entropic.
Mhm.
So by just doing its thing without being conscious, you have a setup for quantum mechanics. You have a matrix of, there is a broadcast that continues that way, and there is my action there. And the two interact into something, into some collision that form particles or whatever that we want to do, that we want to talk about. Now, my recognizing it is something else altogether. But it doesn't mean that it doesn't exist. It is there. So that is it. It's as simple as that. Now, how we evolve to study these things is something else. I hold it that it is by pattern recognition, repetitive, and then tinkering and doing things, and things happen that we recognize the relationship to a pattern that we evolve consciously. Thank you.
Thank you, Manu. Richard. You're muted, Richard.
What Manu just talked about in terms of the fish struck a context for me in terms of the water and the music and the pumping system is all kind of an interconnected context. And if you put the fish in and the fish moves through the water, I was always intrigued with the mechanics of how the fish move through the water. And it's a fishtail movement to get the fish from one side of the pond over to the other side. And the fishtail movement is a processional movement. Whereas you have the relationship between the fish tail movement that creates motion that's perpendicular to the action of that axis. And so it's an interesting information that Manu was sharing that puts context together with methodology or with process, and you end up with systemic and systematic working together to create motion in a context. Just, I'm always intrigued when fishtail movement is talked about, and then I connect it to traversing when you're doing downhill skiing, trying to traverse down the fall line, or when you're tacking in a sailboat across the pond from one location to another. They're all processional sort of actions. And for me and my work, it's when two people, like a helper and a counselor, let's say, get together in a what we call an in-sync relationship or a back and forth relationship. They create motion from problem to solution, so to speak, that's perpendicular to the axis of the relationship between them. And that finally helped me understand the mechanics of why relationships are so important in the helping or healing kind of world. And they're not just subjective. There's an actual, if you want, mechanical explanation as to how two people working together, emotion that goes from problem to solution. Or in a classroom, it can be between student and teacher, and how they create motion that takes a student from not knowing something to knowing something. And to feel that they have been part of the learning and they haven't just been spoon-fed. That you get this really dynamic interaction going on between the teacher and the student. And the other thing is teachers in this synergetic way, teachers always want to be the best teacher they can be, but they can't become the best teacher in that sense unless they have a student to work with. And if the student wants to become the best student that they can be, they often need a teacher or a facilitator. So when you get those two working together, they create this Bucky Fuller synergetic motion, that something that neither one of them could have achieved on their own. And so they both come out winners. The student becomes a top student and the teacher becomes a top student teacher.
Thank you, Richard.
Thank you.
Are you done?
Yeah.
Okay, thank you. This is a wonderful link between Sunday call and Wednesday call, how the fish moves in water and all that. This is, thank you for that. And then little remark about teachers and students. There's a Asian saying, probably it's Japan, maybe it's China, but probably it's Japan, that say that when the student is ready, the teachers appear. So thank you for that. Joe, please go ahead.
Yeah, so basically, just really quickly, no, I mean, I think that this all links together with our Wednesday call. You actually took the words right out of my mouth, Fred, by saying that. Because then you start to think in terms of space-time, and then how change actually happens between entities, so that you start to see that, you understand the mechanics, and then you start to understand the attributes of the fish that actually and then enable it to function. And then once it functions, then you can start to assess what is it that then allows it to do what it did, and then how that relates to cause and effect. And so being able to assess these things and look at things through a space-time lens, and events, this is where we were talking about the observer a moment ago, and we had a long conversation about that and the idea of lag, and how lag has an impact on what we can observe. And we were talking about a moment ago, our sensorial experience. Lag also has a direct impact on what our senses can even process. So that's another aspect of it that's very important to be considering when we're thinking is, what is it our senses enables our senses to process, and then what is it that enables an entity to do whatever it's doing within a particular moment in time, at a particular place. So, and all of that is kind of being able to then dissect what cause and effect is really what is really occurring. And a lot of these ideas, understanding this, is essentially some of the critical parts of really kind of at least building an AI that doesn't think in a linear way.
Are you done, Joe?
Yeah.
Thank you.
Good.
Just a small reaction. You're talking about lag and space-time. I think it was last Wednesday I mentioned that distance is actually
that's huge.
the density of entanglement correlations, and that space-time and distance are brain or mind construction from the information that the universe gives us, that allows us to create the fact that not all information reaches us at the same time, and that we would be overwhelmed. It allows us so that our hand can know how to pick up this cup, and not just try to pick up some star far away. And the density of entanglement is a reflection of the bandwidths available to us at this particular location in the universe. and that the further an object is, the longer the calculation the universe needs to render it for us. So that's good, another good link with last week's
Yeah,
talk.
no, and I actually appreciate you just saying that right now, because there's somebody that I know, and then in a different way, I'm looking at it through a slightly different lens, but they're working on a language, literally, and it speaks to I forget if it's quality or quantity. Either way, it's the same, and they're getting to the same idea, because you're talking about density, energy, and distance. And so, once you look at things through those lens, then what is it? What are the attributes of whatever it is? So then you can take a shape and represent it through a mental state, would be a circle, and a square would be a physical state, and how those two things actually come together. And then you would add color in to understand the qualities of that and the different shades within the qualities of that. And then so that, would be the density would be, you're saying what the qualities are, then you're looking over a certain distance and energy that is actually being exacted. So then you can start to say, what are the qualities of something, and what is the energy that actually can be outputted by those qualities, and then what distance does it cover? And then when you have those in shapes, then you can start to actually explain that very clearly. You can start to see, but this is a whole language system that is built around this in order to but you're saying density just a moment ago actually gave me a different perspective on thinking about that. I think about it in terms of mass, information, space, time, and energy. But
I was mentioning density in density of entanglement correlations. That's basically the more things are entangled together, the closer they look, the closer they appear to be.
Right. As far as thank you.
And the reason behind that is that, as the assumption or the calculation or the presumption is that the universe is a giant quantum computer, it's the more entangled, the more correlation there are, the faster the calculation, and then it appears faster. So it seems to be closer. Does
that have a relationship with recursion?
Probably, in a way, not obvious, but probably yes.
Thanks.
All right, thank you, Stephen, please.
Hey, you said a really famous quote: "When the student is ready, the teacher appears." I started studying the Kabbalion, so Hermetic studies, and the initiates there had another saying. They said, "When the teacher is ready, the student appears."
That's true.
And that's really profound.
It goes both ways. It goes both ways.
It goes both ways. And inspired by all this, I checked about Galileo. And Galileo heard about somebody had invented a telescope in 1608 for military use. In 1609, getting all these reports about how you make a telescope, Galileo builds his own telescope. In order to get the telescope to work, he starts learning how to polish the lenses and affect the lenses. His first telescope only magnified 3 times. But still, with that telescope, he saw craters on the moon. He saw the Venus in phases. He saw the 4 moons going around Jupiter, and blew the pants off of Copernican theory. And so, interestingly, his techniques for grinding lenses later they could go up to 30 times magnification just by using his techniques and refining his techniques. So it blows my mind. I mean, what is the relationship of teacher and student? You look at a guy like Galileo, his teacher in a way is this Dutch guy who's inventing a military device. And yet he takes that thing and says, I want to look out. I want to look out and see what's out there. And then somebody else takes a stupid thing and invents a microscope and starts looking in. So here we are, human beings looking out, looking in. And I heard another interesting parallel today as I was studying the Great Commandment in the New Testament, which comes, by the way, from Leviticus in the Old Testament, a combination of Deuteronomy 6:5 and Leviticus 12:7. Jesus is being talked to by the scribe. It says, what's the greatest commandment? And Jesus says to love God. And of course, to cut off all the conversation about how you do that. And he said, the second is like unto it, love your neighbor as yourself. This referred to two Hebrew scriptures that were linked together in the Hebrew legal system because of a technicality. The beginning of both of those scriptures start out the same way. And in Hebrew legalistic terminology, it bound those two to make them equivalent. And so Jesus takes these two profound scriptures, sticks them together, and challenges the scribes. And in one version, the scribe actually answers himself, and Jesus says, hey, dude, you did a pretty good job. There are three different versions of that Great Commandment story in the New Testament, Mark and Matthew, and then Luke, who does a different job. Anyway, it's just interesting how who's the teacher and who's the student. It just came up for me. It's a wonderful thing. I just thought I would share that. I have other things I'm noting here, but that I'm complete for now. Thank you.
Thank you, Steve. I thank you for mentioning Galileo. Everybody needs a hero, and this is mine. Yeah, I see Richard says this because he's part of the Galileo Commission. All right, any more questions? Shall we keep going this discussion, or shall we read a little bit about information and computation?
We
I'd
have
like to-
time for reading.
Let's
Yeah, me
read.
too.
Let's read.
Let's read. Let's
Let's
read.
read a little bit something, huh? Okay. Thank you, Steve, for sharing.
Okay, I'll read. I'd like to read. Chapter 2, Computation. What? Chapter 2.
Please go ahead.
Yeah.
Go ahead, Stephen. You read.
Thank you. Chapter 2, Computation Information. I began the initial meeting of my MIT graduate course on information in the manner I began all of my courses. First, I said to the 20-odd students, you ask questions, and I think we might have read this last time.
Yeah, but we say we're going to start again. We read
Oh, yeah,
the
but we
first
needed
part.
to start there because it was, yeah, that's why we did. Okay, good. If you don't ask questions, I'll ask you questions. Third, if you don't answer my questions, I'll tell you something I think you ought to know. Any questions? I waited, no response. Something was wrong. Normally, MIT students are more than happy to try to stump the professor, particularly if the alternative is that the professor will try to stump them. I moved on to step 2. No questions? Then here's one for you. What is information? Nothing. This was even worse. After all, these students had been stuffing themselves full of information since freshman year. If they didn't regurgitate some of it, I was going to have to resort to step 3. Okay, how about this one? What is the unit of information? At once the class responded, the bit. What do my students' answers or lack thereof reveal? That it is far easier to measure a quantity of information than to say what information is. Very interesting. Just like it's easier to point out this is a living thing than it is to define what life really is. And more broadly, how much is frequent?
Famously, the same goes with porn.
With what?
Porn.
Form, exactly.
Yeah.
It's U.S. Senator or congressman that said, I cannot define porn, but I know what it is when I see it.
And we do the same thing with pornography. Anyway, I think we said, and more broadly, how much is frequently an answer question, is frequently an easier question to answer than what is. What is energy? What is money? He left out pornography. There are hard questions. Much energy, how much energy does it take to whatever? How much money does it take to whatever? These questions have precise and available answers. What is a bit, I asked. No replies. Came thick and overlapping. Oh, now replies came thick and overlapping. 0 or 1. Heads or tails. Yes or no. True or false. The choice between two alternatives. All of these answers are correct. The word bit stands for binary digit. Binary means consisting of two parts, and a bit represents one of these two alternatives. Traditionally, these alternatives are referred to as 0 and 1, but any two distinct alternatives, hot, cold, black, white, in, out, register as a bit. A bit is the smallest unit of information. A coin toss yields 1 bit, heads or tails. 2 bits represent a slightly larger chunk of information. 2 coin tosses yield 1 of 4, or 2 times 2. Alternative outcomes. Heads, tails, tails, heads, tails, tails. Similarly, 3 coin tosses yield 1 of 8, or 2 times 2 times 2 alternatives. He's stressing the binary here. As you can see from even these examples, as you keep on tossing coins, the number of total alternatives, total possible outcomes of a series of tosses, grows rapidly. In fact, with each subsequent toss, remember each toss will yields 1 bit, the number of total alternatives doubles. So to calculate the number of alternative outcomes in a given scenario, you simply multiply 2 by itself a number of times equal to the number of bits. For example, 10 bits gives 2 multiplied by itself 10 times, or 1024. 2 times 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 2 equals 2 to the 10th equals 1024. By the way, that's twice 720, just curiously. Just thought I would point that out. Isn't it? No, it'd be 14. I'm sorry, I totally screwed it up. Forget everything I just said. Blank, I'm coming back. 1024. And I don't know what that little a means. It also means and 10 to the third, 10 to the power of 3. To put it an answer, go ahead, let's pause.
I think that's a good time to stop. Joe has his hand up.
Oh, okay, good.
Thank you.
Yeah, I mean,
Or Joe.
there's a couple of things here, and I think one of them is really thinking about, and this is something I would even think about, I wouldn't mind getting Anne's thoughts on it, in the sense that how the students, how students actually couldn't actually answer what information was, and the reason, the significance of that, because there is I think a deep significance, because what it is that we're taking information in, and we're taking it in as being a representation, a correct representation of reality. And if you don't even know what it is, and even if you're going to break it down to bits and things along those lines, it's data. And understanding that data and how data is biased is really critical as far as imagination is concerned, because you can imagine things outside of the information that you're being fed. So we were just talking about consciousness a moment ago. I mean, one of the things is that we can actually start to think about things not just in terms of information that is being fed, but we can also imagine things to be different than they actually are. So, and then that allows us to, I find it interesting that even that the students, you often hear people say, if I had more data, I could actually quantify anything. And it's like, well, do you even consider what data is? So, and by posing that question to those students, that is something that if the students can't explain that, then they're really just becoming very mechanical in how they're functioning. So anyway, that's just a thought.
Thank you, Joe. Any comment on Joe? No. And
Yeah.
who's next? Who's next? Is that Anne or is that Manu? Sorry, Manu. Manu was first.
And if you want to go first, you go, because you are a lady.
Carry on.
I respect ladies today. Go first. Go.
Oh, thank you. Mine's very quick. The one about Joe saying that no, actually this the question of how, what and how, right? There's a question on how that even the many part that even that can stump students, right? If you give them a hall and you ask them how many people are in there, they actually try and answer an exact number, and I tell them, okay, you can say too many. Too many is fine, more than I expected. Or it's double the number that we expected, or even the fact that I think it's around 200 people. No way will they'll get stumped at even giving an answer like this for many people in I know in Asia lah. Yeah, so just to put it out there, the how many question. Yeah, otherwise what is even tougher? Okay, thank you.
Thank you, Anne. Manu, please.
Okay. First thing, we just recognize patterns and things that are whole. That's what we recognize. Don't talk about money. Usually, money is an accepted thing, and we give it characteristics or dimensions. We say, for example, the four that are usually, quoted is a medium of exchange, is a unit of account, is fungible, is divisible, and then is a store of value. So you see that is at least 5 characteristics of something that we call money and that we use all the time. So that money is a pattern that we recognize that is multidimensional and that we reduce to something that we understand, that is practical for us to use. The second thing that is important is that in order to recognize that pattern, there's got to be repetition of bits, a repetition. It has to repeat all the time for us to be able to, on that fuzzy of the IVM, recognize something. And that recognition is where arises, that repetition is where arises the power of 2 to the power of thing. That's why we use the exponential and the logarithmic to try to understand better. We created those tools to understand better what is going on, because it is spherical. It is going on like that in many directions. But remember, we're only capable of 0 or 1. We see, we didn't see. And to say it's something else, we have to wait for the next iteration to see or not see. That's why it's 2 to the power of something. 2 to the power of a number of observations. And every observation can be 0 or 1. I wanted to make that link, that mathematical link, for us not to be lost with it. The power or the exponential or the logarithmic arises from the fact that we are in and we can only see one state at a time, 0 or what we call 0, or we can call it 1 and 2. We can call it 10 and 20. It doesn't matter. It's just the experience. And then we have to wait at the next iteration to count again. That was my point. Thank you.
Thank you, Manu. Richard,
I I came up with another what is question. What is a fuzzy bit? And trying to answer it, a fuzzy bit is what's between two bits. And again, in my world, fuzzy bits aren't allowed. You've got to get off your butt. Maybe that's a spelling error, but you've got to get off your butt and choose one or the other. Whereas now we're learning that fuzzy bits, in other words, ambivalence, I'm weighing both of them. I'm kind of holding both at the same time. Is quite common in human sort of dialogue with themselves or in dialogue with others. It's quite acceptable to have that third in between. What I've just coined in my own mind is a fuzzy bit. Any questions?
yes. I think you cannot have one fuzzy bit. You can only have a
Bit.
group of bits that are fuzzy. Because
Yes.
if you can have a fuzzy bit, that means you do not have a unit of information. You need to go deeper.
Yeah, that makes sense because in the 0 or 1 or yes and no, you've got two bits and you can have a fuzzy bit in between them.
No, 0, 1 is it's two states of the same bit.
That's it.
Well, then you can have
Zero,
a fuzzy bit.
0, 1 is two states of the same bit, but there's only two states. There's nothing in between. It's like quantum. It's either one or the other. That means you can have fuzzy bits if you have, let's say, a group of 8 bits, and some of them are not well defined, or some of them contain errors. Then you have some fuzzy information in there. It's indeterminate. And there's if you go further up in the aggregation of information, you have what's called fuzzy search. When you type a word that has a typo in it, that has a misspelling in it, if your search, and today every internet search is allow for fuzziness, that is, you still get the correct result, even you put 2F or you put 1M only instead of 2. Then the software can do it. But this cannot happen on one bit, otherwise it would not be the unit of information. It has to be done on an aggregate of bits in order to be fuzzy, I believe.
Does that mean we can't have ambiguity or ambivalence?
Well, one bit is, by definition, one bit has two states, not three. So you have to refer to the definition. It can only have one. It can either be 1 or it can be 0, or it can be faulty. That is, when you go down to the machine level, bits are volts of current, and the volts of current has to be separated enough so that a distinction can be made between 0 and 1. And if the current is not strong enough towards one end or the other end, it can be misread, but it will not be read in between. It will be misread. It will be read at 1 instead of 0 or 0 instead of 1. Because by definition of a bit, it's either 1 or 0. It cannot be in between. So what you can have in between is when you have 8 bits, for instance, and you have 2 bits which are swapped or inverted, then it becomes some fuzzy information. Can you still retrieve the correct information from some incorrect bits inside a set of bits?
So that means that I'm possibly misunderstanding the binary notion of bits. In a relational sense, the binary between live or die, you make up your mind. You've got to do one or the other. And
Yeah, but these are elaborate concepts. We're not having such elaborate concepts here. We just have one container that has current in it or no current in it, or some voltage in it or some other voltage in it. A coin can be one face or heads or tails. And of course, a coin can be on the side, but this is by definition, we're talking about virtual coins, not physical coin that can land on the side. That is either one or zero. They cannot, by definition, they cannot be in between. But for more elaborate concept, more complex concepts, then you can have fuzziness in that. Yes.
Oh, okay. Thank you. That's
And one bit, the bit is not the one or the zero. The bit is the entity that can have two states, either one or zero. That's the definition.
so the difference between a definition of what a state is and a definition of what an entity is. You can have an entity with two states, right? Or you can have two entities that have a binary kind of dynamic to them.
Yes, an entity doesn't have to be physical. It can only be it can be a complete abstraction,
Right.
like mathematical abstraction for some reasoning. But at the moment where you go to the physical, then you have to have a physical entity that says the current is one or the current is zero. I mean, say it's a one or zero based on the voltage that's in it at that moment.
Oh, thank you. Thank you.
You're welcome, Richard. Are you done?
Yes, I'm done.
Yes. Okay. Joe, please go ahead.
Yeah, just not to harp on my previous point a little bit, but I think that, using the example of money that Manu used earlier it's an important one, because let's just say you have information that's coming in, and that's what essentially money is. It's the idea that it is carrying information. It's something that where if you don't know what information is, you really can't determine the distinction between the signal and the noise. So, and that's where it's kind of like where the noise, and I was in a conversation about this a couple of weeks ago, is how the noise is inflation. So inflation is a way of kind of distorting what the signal actually is. And if you get into this idea of price signaling, that's what it is, sending a signal about what, about the resources that exist in the physical world. And so when we think about terms of just, what is information, this is where I was kind of saying, if you can't answer that question, it can become very distorted. You could have a distorted perspective on reality, because you would just be looking at the numbers per se, as opposed to understanding what money is actually representing, and then being able to do analysis off of that. So this is all coming back just to the comment, is that if in the book, if you can't explain what information actually is, or then you're really, in one aspect of this is you can't even explain then what money does, because it carries information, and what it and how that signal gets distorted, and what it really represents. And so this is the whole reason, is to really kind of have that understanding as to what information actually is. Anyway, I think it's an important point, and I thought that the way Manu had presented it was interesting, in the sense of bringing up the idea of money. So even, well, I won't go into it. That could turn into a long conversation.
Thank you, Joe. Anybody else? No. It's 38. I think it's time to go to part our ways. So, Lee, how are you feeling and what is your takeaway today?
I'm feeling pretty good. Learning how little everything could be or are, and associating it with a large entity such as the fish in a tank. I like that perspective to know how easily everything is intertwined together so that this universe can develop into what it is. And I have been very excited to be part of this, especially this book. It's giving me a lot more knowledge than I thought I did know. And I pass it on to you, Anne. How are you feeling? And what is your takeaway?
Thank you, Lee. I'm very grateful, so grateful for this group, for all of you, because of the conversation we had today, and every week is crazy. So first, I want to thank Steve, because now I can, knowing how the having that transcription down. One of the things that I've always had difficulty with is that, we are discussing, right, and then I want to take down something, and then but the conversation has moved on, and it's very interesting, and I can't go back, can't recall the exact words. Usually it's the exact words that I wanted. So, like, say, for instance, Fred, it was the conservation law, right? And he gave of energy, and there's something else. So now it's easy. I just go back, and now I go to the transcript. I just pick out the things I need, or the ones that I may want to go a little bit further, and without having to go through the 2 hours. So it's perfect. Just want to say thank you. The other one is the the one, Fred, you're talking about when the student is ready, like the teacher appears, and then for Steve, you went on and said when the teacher is ready, the student appears, right? So I went in to check a little bit, and there's another saying that say when the student is truly ready, the teacher disappears. So I thought, wow, so many ways to work on this. And the third one that I took away is this whole idea of micro, macro. Fred, the way you explain the quantum physics, part of it. And so this one really helps a lot, because literally is where certainty ends and the uncertainty kind of takes over. And then and Manu, when you went down the path of explaining it, then I can see like there's this the two. Yes. And for us, all the things we've been discussing, the universe, the generalized principles, they have been very, very clear, very, very clear, So, and you're right, it determines the world, and that one, it's a fact, right? But then with the quantum physics, it was like, it came down a very different path. But I'm very, very happy that it got cleared up for me, and that, I can't wait to go on with the book. Okay. Yeah. Thank you. So over to Richard. Richard, how do you? Oh, he's on the phone. Sorry. Steve, Fred is last, right? Okay, so Steve,
Yes.
How do you feel, and what is your takeaway today?
Well, I'm feeling pretty good. I thought our conversation was pretty dense, but I got caught up on a couple things. And it was interesting because I was musing on this idea, and suddenly Fred said that we can't see micro, we can't see quantum things, we can't see electrons. We need a system. We need to develop a system to see that. And this goes right along with the teacher. When the teacher's ready, the student appears. When the student is ready, the teacher appears. When the student's really ready, the teacher disappears. Somehow human beings, we were not created to see quantum reality without developing a system to see it. And we started talking about these fish. And I've been thinking about, what does a fish do? Well, a fish does what's in front of it. And I think that's a perfect model for a human being. You know, what should I do? I should do what's in front of me. And if I'm Galileo, what's in front of me is some Dutch guy invents a telescope for military. And Galileo goes, well, what if I take that telescope and look out and see what else I can see? All a human being has to do is do what's in front of them. All I have to do is do what's in front of me. That's my purpose in this life. How do I know? Because that's the only thing I can do. Oh, well, that was where I went. I went off into huge stuff. So thank you. And thank you, Anne, for because of Fred's suggestion, because there used to be the transcripts come in what's called a VTT file, and it's really difficult because it lists in the first section it lists the time segment, in the second section it lists it numbers the segment. In the second section it lists the times for each of the segments listed above, and then the third section it gives the text. And so I take that and throw it into a spreadsheet, and then I have it numbered 1, 2, 3, 4, and then I sort and get all the numbers out, and then I start mixing and matching, and then I throw all that to a text file. So if you see the old ones, if you do get to the old ones, they'll be a bit more difficult because there's a lot more data there, and you have to go down lines. This new one does put the text by the time segment. My big regret is that it's usually just, a few words long, and you have to read like 13 lines. But at least when someone talks, everything's right there. So that worked pretty good. Thank you for acknowledging that, Anne. And I just want to apologize to Manu because I thought tonight I was going to be able to get all these archives out for all of our past things, and I distracted myself and didn't do it. So Manu, although I'm sending out my commitment is, and I'm doing 50-50 on sending out the invitation within 24 hours after the call. So the transcript and the link is right there within 24 hours. That's my goal. And I hope to catch up on all that. But Manu, and I truly apologize for any stuff. And I was looking. I have this thing I looked up because 1024 seemed to me to be a big deal, and so I did a little work on 1024, and found out that Buckminster Fuller does discuss 1024 in some kind of a context, and I thought that Manu was going to come in and save me. But I'm just going to paste. I think I might be already pasted this. So I pasted it twice now. Talks about how the 1024 number is. He describes how the tetrahedral growth
to the power of
is governed by the formula n to the y power, where 2n equals
5.
10 to the 10th, 2 to the 10th equals 1024. And anyway, there's a little bit of conversation there. And I went through synergetics trying to find that 1024 because it really stuck out like a big number for me. And it wasn't in synergetics. It must have been in some other book. So anyway, those are my things. And Richard has stated that his daughter's called. Joe, have you shared how you feel and what your takeaways are? Would you like to do that now?
No, I mean, no, I haven't. So, I appreciate very much, Steve, what you just said, and doing what is just in front of you and focusing on that. I think that one of the things that tends to get us in a little bit of trouble is that when we're focused on, doing things that we think are going to have this huge, massive impact, but we're doing it at the expense of the person right next to us, and that that the idea that is, well, I'll do this great thing, but the person next to me doesn't matter, and that's just not a model. I like the way you shaped it in the sense of the fish. And sometimes I think it's better that we get our lessons from nature rather than getting our lessons from what we construct. So, in any case, as far as everything else is concerned, I had a really good time. And actually, this has been very helpful for me, primarily because, a lot of the models that I'm working on are actually talking about, it's very algorithmically focused at this particular moment in time. So the quantum questions that were spurred on by Anne at the onset is especially helpful for me. And some of the explanations that Fred and everybody provided were very helpful as well, as far as getting just to think in terms of quantum. And that's one of the things about the book that I really am excited about as well. The part of the book, again, I mentioned it already, I won't keep going over it, but really understanding what information is, I think, is actually critical. I was talking to somebody last week about what they consider to be understanding, or what the AI industry believes to be, or how they categorize, or what they consider to be understanding, and it's data, information, context, and then it's understanding. And I don't necessarily think it's quite that simple. So when we're talking about what these things actually are, and I mean it, kind of going through it, what information actually is, that then I think that's it's helping me identify how something then becomes meaningful. Because if information is something that is distorted and there's noise that's associated with it, it loses its meaning. And so the ability to actually understand what it is and when it's distorted is critical. And that's, is true for a machine as it is for a human being. Anyway, those are all, I'm just rambling. There's quite a few things that I'm taking away from this, so I appreciate everybody's contributions. So with that, Manu, I don't believe you've gone yet. How are you feeling? What are you taking away from today?
Can you hear me? Okay. I really feel good. The two ladies said they were not confused. Anne and Lee said they were not confused. I mean, that's rare. So Fred will have to be happy that they say so. Otherwise, I put a comment there to respond to Steve 10 to the 1024. Why is this so central? You remember the IBM is 12 dimensions. We being inside need to choose two of those that are opposite like this as referential, as poles. So there remain 10. That define, you can go to the isocosahedron to see that the 20 faces. So 2 to the power of 10, we need to turn dimensionally 10 times to be able to completely circle and define the icosahedron, the 20 faces of the icosahedron. So 2, we saw that at each time is either 1 or 2, 1 or 0. So 2 to the power of 10 is 1024. That's why in programming, in circuitry, in electronics is so important. The 2, 8, 32, 64, 128, etc., to the 1,000, 1 kilobyte. So that's my takeaway. There's so much. So I'll let the other guys say what they took away, and I'll just be a lazy guy and then profit from it. I feel like I've grown, specifically by the fact that the two ladies say they're not confused. That's my takeaway. Steve, how you been? So is Steve. Okay, so is Fred. Fred, how do you feel? Okay, Richard.
Richard
Oh,
is busy.
Richard.
Richard's on the phone
What's
with his daughter.
is it still?
Richard's on the phone with his daughter. So
Okay, so Fred, you can take first.
yeah.
What state
Okay.
are you? How do you feel? And what do you take away?
There's a lot of takeaways today. The first one I'd like to share is that 2 to the 10 is 1,000, 2 to the 20 is 1 million, 2 to the 30 is 1 billion. You can run with that. Once you have this, you can. Once you no. Once you have this, your brain is calibrated, your mind is calibrated. You can estimate the power of 2 of anything on nearly, and it's interesting to do this on the fly. That is 500 million would be 2 to the 29, and so on. That's basically 2 to the 10. When the student is ready, the teacher appears. When the teacher is ready, the student appears. When the student is truly ready, the teacher disappears. Thanks, Anne, for that. But in fact, we're never ready. Ready is a state that is triggered during the jump. Until you jump, you're not ready. So if you wait to be ready before you jump, you never do anything.
And
That's,
I put a corollary on that. I put a corollary on that underneath. That's why you do it.
Yeah.
Just do it.
You said do it, and then I commented, oh, don't. Sometimes you should not do anything. But but it's if you allocate a bit to the do it, then it's either 1 or 0. There we go.
My goodness, what a masterful way to apply the paragraphs we read in today's takeaway. Good job
Yes.
on that one.
Thank you. Thank you. Talking about being ready, thanks for sending the text files. I had somehow the idea of taking it, processing it, and removing all the crap out of it. Reassemble the sentences to real sentences, automate that, and send it to you. But I did not do it because it seems like we're all falling behind, not because we're getting slower, although we might be, but because we are starting to feel the pressure of the end being near, and we start to cram more things to do into the reduced allocated time for it, which is probably a bad idea, but seems like that's what we're all trying to do. Conservation laws. There is a law of conservation of information, and that's a universal law. If it is violated, that is, if information is destroyed, then the universe cannot exist as we know it. So this is there's a law of conservation of information. Even the information that falls into a black hole or a book that burns somehow is conserved. And Steve, you said we were created to see quantum. We were not created to see quantum. We need to have a system, a physical system for that. I don't know. Maybe we were not supposed to see all of that. It's too complicated. Until we can make a drawing and stick it on the fridge that will help us to understand, we should not be able to see these things.
No, I was quoting you. I quoted you, Fred, when I said that. So
I know you were quoting me, but I didn't say we were. Did I say we were not created to see quantum?
Well, I don't think you said
no,
created.
I said no. I did not use. I probably did not use created. I
did not use created. You did not use created.
Our sensory systems are not designed or calibrated to feel or see.
Calibrated. That's what you said.
That's probably what I said. Yes, and that's yes. That thing is continuous. Continuous. I think is Joe mentioned continuous as in continuous interaction and series of interaction. I think it's an interesting thing to look at continuous because we have analogic and digital, and we see analogic as a continuous thing, and digital is sampling. Like for instance, music used to be played on instruments like a violin, it's continuous wave, whereas when you have a recording, it's a sampling of the wave. Somehow, I've had discussions with a few people doing equipment, doing not doing software, but doing the hardware. Somehow, I feel there's a return towards an analogic data collection where the sampling is quantum. That is, the sampling is based on Planck time. The sampling is every 1 minus 10 minus 34, 10 power minus 34 seconds. Instead of 128 samples per second, you get a gazillion of information per second. And there's a return to that because somehow there's a lot of lost information during the sampling, and probably it would be useful to do a pre-processing on analog information before sampling is done, before we amputate our data with from a lot of information. Anyway, that's continuous versus discontinuous, I would say. Richard, will you say goodbye to us?
I think he's
He's on the phone with
Richard.
his daughter.
oh, he's going to come and say something.
Yes.
Okay, good.
All right. Bye-bye. Bye-bye, Richard. Bye-bye,
everyone.
everybody.